Dust in the Wind from the 1970s, before most of you were born. All right, so let's see, we're going to do a couple of word problems here. And I want to show you kind of an approach I like to teaching word problems. Students' hardest part of these problems is getting everything set up. Now, this just sort of gives you a procedure that you can go through and work. What I want to try to show you is algebra saves time. The problems that I'm going to do two examples, could be done by trial and error, but algebra speeds up the process. So I'm going to go down to example 10, and you don't really need to write down what I'm doing first of all, because I'm going to do this by trial and error first here. So it says a parking meter contains just dimes and quarters. It contains 100 quarters. The value of that money is $14.50. So how many of each coin is in the meter? The purpose of this problem is to think mathematically, not to solve a practical problem. If there was 100 coins in a meter, you would probably just dump them out and find out how many of each you have. Okay, so the purpose of this is it's an exercise. Kind of like when I'm playing the guitar, I do exercises all the time, finger exercises that speed me up or help me to learn a certain difficult thing. So that's the idea. This is an exercise, all right? So think of it that way. So what I'm going to do is I'm just going to do this by trial and error. I want to show you kind of how I would solve this problem by trial and error. And you don't have to write this down if you don't want to. You can if you want to, though. So let's just say that we have dimes. We know we have dimes, and we know we have quarters. So here's the idea. All right, we know we have 100 coins. So I'm going to take a wild guess. I'm going to say 40 dimes. Well, that would mean I would have to have 60 quarters. Okay, well, how did I figure out the 60? Well, I did 100 minus 40 is what I did. Okay, now let's count our money and let's see what happens. So if we count the money, what we would do is a dime is worth 10 cents. A quarter is worth 25 cents. And we would add that together and we would see if it's equal to $14.50. So I'm going to use the calculator to do some of this. I mean, what I would have here is if I did this, I would have $4 there. So if you have 40 dimes, that's $4. And then if you do 0.25 times 60, that would give $15. Okay, so I think I'm right on that. So that's just 0.25 is a fourth of something. So a fourth of 60 would be 15. Okay, so that's wrong because that's $15. Whoops, not $15. 15 plus 4 would be $19. So that's wrong. So what I could do is I could just start over again. Okay, so I'm going to adjust this a little bit. Maybe I have too many quarters. So I'm going to go like this. I'm going to say, let's move that from 40. Let's move this up maybe to 60 and then 40, and let's do it backwards like this and just kind of see what happens. And I'm not going to do this over and over again until I get it. I like to teach it this way because it helps you see certain connections in the problem. Okay, again, how did I get 40? I did 100 minus 60. That'll be important when we set up the equation. So I count my money. A dime is worth 10 cents. 60 dimes would be worth $6. A quarter is worth 25 cents. So if I multiply that out, that would be 40 quarters would be, divide that by 4, that would be $10. Okay, like that. All right, so that's $16. So we're getting closer. So we're going to adjust it. I'm just going to try it one more time. And if it doesn't work, that's good enough. So I'm just going to scratch this out and I'm going to try again. All right, so this time what I'm going to do, let's move that up to say 65. Okay, then this would be 100 minus 65. So that would be 35. Okay, so notice that 65 and 35 add up to 100. Okay, so I'm going to count my money again. I'm going to just try it one more time to see if I get it right. So 10 dimes. If you have 65 dimes, that's $6.50. If you have 35 quarters, it's a little harder for me to do in my head. So I'm going to take my calculator and just do 0.25 times 35. Yep. And when I do that, I'm going to have $8.75. I think I'm pretty close, but I'm not quite right. So if I do $8.75 plus $6.50, I end up with $15.25. So I'm still not there. Now, see, you could do this over and over again. We could just keep adjusting, and we could eventually stumble on the answer. So I hope that I've done enough on here to help you understand how the equation goes. Well, the equation goes like this. It's just what you're going to do is you're going to just pick a variable. Let's let x equal the number of dimes, kind of like what we were doing when we did trial and error. Okay, then what that will mean is that will mean 100 minus x is going to be the number of quarters. Okay, now think about that. That's what we were doing when we did that over and over again. We have 100 quarters. So if you had 10 dimes, you know you have 90 quarters because 100 minus 10 is 90. So you got to understand that. Now we just build the equation. So we have the value of the dimes plus the value of the quarters. It's good to write this down in words for study purposes. The values of the quarters is equal to $14.50. So the value of the dimes is 10 cents, 0.10 times x. X is the number of dimes, just like we did over here, 65 dimes times 0.10. The value of the quarters is 0.25 times the number of quarters, which is represented by 100 minus x. And that money totals up to $14.50. You need to be able to look at that equation and understand what everything means in the context of this problem. X is the number of dimes. If you multiply the number of dimes by 0.10, you have how much money you have. This is 0.25 is the value of quarters. If you multiply it by the number of quarters you have, which is 100 minus the amount of dimes you have, then you have your money. And it adds up to $14.50. Now, algebra, like I said, is a time-saving device. It really is, believe it or not. So what we do is solve it, the equation now. So that's 0.10x. You can do a distributive property. 0.25 times 100 is 225. And then I would have minus 0.25x is equal to $14.50. You have like terms. So these two things right here are like terms, so put them together. Okay, so if you did that, you can use your calculator if you feel like you need to. We just take 10 cents minus 25 cents would leave you in the hole by 15 cents. So that's going to be negative 0.15x plus 25 is equal to $14.50. Okay, now it's standard equation solving. Either move the 0.25 or subtract it from both sides. Okay, when you do that, you'll be left with this. You'll have negative 0.15x is equal to, and I'll take my calculator, 14.5 minus 25, and that'll give negative 10.5. And then I finish up by dividing by the negative 0.15. All right, and that'll give what x is, and x is the number of dimes. Okay, so I just take the negative 10.5. The two negatives are going to divide out, so you'll get a positive number. If you didn't get a positive number, it wouldn't make any sense. So we get this. So that is 70 dimes. Okay, so that gives you that. Now it's easy to find the number of quarters. So the number of quarters would be 30. So you'd have 30 quarters. Because there's 100 coins, so that would be the answer to the problem. Now, the other thing that you want to do, and students like never do this, and you should always do this, you can tell you're right. All you got to do is count your money. Now, don't plug into the equation. That doesn't prove anything. Just count your money. So if you do, the value of your dimes would be $7. Okay, 70 dimes is $7. the value of your quarters. You could use a calculator if you needed to on that. If you take 0.25 times the 30 quarters, that value would be $7.50. Then if you just add the money, that gives you $14.50, which was what we're supposed to get anyway. Okay, so if I would have guessed 70 and 30, I would have got the problem quickly that way, but it's hard to guess. But to me, this kind of trial and error guess and check method helps students to understand how you build an equation better. So on a word problem, don't just struggle and throw your arms up in the air and say it's too hard, because it isn't too hard. Okay, play with it. Play with the numbers, trial and error a little bit if you have to, and that'll help you understand the equation. All right, so let's go to this next example. Okay, so this one says if you have $500,000 in an IRA at the time you retire, that would be nice. You have the option of investing the money in two funds. Fund A pays 5.2% annually. Fund B pays more, 7.7% annually. How should you divide your money between Fund A and Fund B to produce an annual interest of $30,000? Again, I want to stress this is an exercise. This is a mental exercise. Like when I play guitar every day, I do exercises. I play scales. This is a mathematical exercise. It's not a very practical problem, but don't think of it that way. Think of it as an exercise. So we're going to play with the money. All right, so what I'm going to do is we have Fund B, Fund A, which pays 5.2% annually, and then we have a Fund B, which pays 7.7% annually. We're going to play with it. We're not going to do it algebraically yet. So we're going to pick some money. We have $500,000. All right, so let's just divide it up. Let's put $300,000 in Fund A. So how much would be left over? There would be $200,000. How did you do that? You did 500,000 minus 300,000. I mean, the answer just kind of comes to you in your head, but that's what you're doing. So see, just by doing this, we're already making connections you're going to see in the equation. Now we figure out the interest. So what we do is when we do 5.2% of a number, you got to move the decimal to the left 2 to get 0.052 times 300,000. And I'm going to do that on the calculator, and that will give the amount of interest that's earned by that then. So I'll do it on the calculator. So I'll take 0.52 multiplied by 300,000. Okay, I think I got the right number. Do I have the right number of zeros in there? Oh, I didn't do the decimal right. I knew I was doing something wrong. Okay, so 0.052, and then multiplied by 300,000. A percent is out of 100, so you're dividing by 100, which causes the decimals to move back. Okay, that's more like it. So that's 15,600. Okay, now what we're going to do is take the 7.7% of 200,000. I do that times 200 grand, and that gives me this. That gives me $15,400. I'm pretty close. I did pretty good. Now, if I added these together, if I did the 15,600 plus the 15,400, that would add up to 0, 0, 10, carry the 1. That would be 31,000. Now that's wrong because it's supposed to add up to 30,000. But see, just by doing this, this helps you understand how the equation goes. So what I'm going to do now is I'm going to have you pause the video, and I want to see if you can build the equation and solve the problem. Okay, and resist any temptations to resume the video. I'm not kidding. People do this all the time when they're learning word problems. They throw their hands up in the air and say it's just too hard. It is not too hard. Okay, give it your best shot. Think about it. Okay, and if you get past that, if you're able to create it on your own, then you will remember it. Okay, so go ahead and pause, and we'll see how you do. Okay, so let's see if we did. Okay, so the answer is $340,000 in Fund A, $160,000 in Fund B. So here's how I put this together. I first of all, I start with what my variable is. X is the amount in Fund A. Now you could also let X be the amount in Fund B. You'd still get the same answer. So that's up to you. But what you have to understand is the rest of that $500,000 gives you what's in Fund B. So Fund B is all of your money, 500,000 minus the X. So think of it as the whole minus the part gives the rest. The structure of the equation is like this. The interest on Fund A plus the interest on Fund B is $30,000. So we're going to do 5.2% of Fund A's amount, X, plus 7.7% of Fund B's amount, and that's equal to 30,000. If you read the problem, 30,000 is the amount of interest. Okay, so you got to get your numbers in the right order. Now, excuse me, throat's getting dry. Right, so what I do now, solve the equation. The rest of this is equation solving. So I did a distributive property, use my calculator, collected like terms, 0.052 minus 0.077 is negative 0.025. I'm going to have this. Then I subtracted 38,500 from both sides, then divided by negative 0.025, and then that gave me 340,000. So when you do this right here, that calculation is what gives you 340,000. Oh, gosh. Okay, so now what I do is I take 500,000 minus the 340, and that gives me this. That gives you the rest of your money. Okay, that's how you get what's in Fund B. Now, this is how I checked my answer. So notice what I did is the interest on 340,000, the interest on Fund A was 5.2%. So when I did this, I got 17,680 in interest. Fund B has 7.7%. I do that interest, I get this. Notice those two interest amounts add up to 30,000, so it's right. So you close off your word problem by checking, and you check it the right way. You don't plug into your equation. That doesn't prove anything. Just doing what you're supposed to do, checking your interest, is how you would tell you have the right answer to the problem. Okay, so that's it. All right, so that's a couple of examples. That'll take care of that, and I'll go ahead and get this posted. Good luck on your word problems. Don't throw your hands up in the air. Work hard on them. Play with them. Have fun. Okay, and if you can get word problems down, that's like the big thing in the whole section. Then you can do anything. All right, that's the way I look at it. Everything else will be easy for you. So good luck.